Welcome to our comprehensive exploration of code quality in DevOps. Today, we'll dive deep into one of the most critical aspects of modern software development. Code quality isn't just about writing clean code. It's the foundation of successful DevOps practices and efficient software delivery. In this session, we'll explore what code quality means in practice, why it's crucial for DevOps success, and how to measure and improve it using modern tools and techniques. We'll also look at real-world examples and practical implementations that you can apply in your own projects. By the end of this session, you'll have a thorough understanding of code quality principles and practical tools you can use to enhance your development practices. Let's begin this exciting journey into the world of code quality. Let's start by understanding what we mean by code quality. Code quality is a comprehensive measure that encompasses four fundamental aspects: reliability, maintainability, efficiency, and adherence to best practices. Think of code quality as the foundation of a building. Just as a building needs a strong foundation to withstand time and usage, your code base needs high quality to support ongoing development and scaling. This isn't just theoretical. Poor code quality projects may lead to weeks of delays and substantial cost overruns. Let's break down each component. Reliability refers to how consistently your code performs its intended functions without failures. This includes error handling, edge cases, and stability under various conditions. For instance, consider a payment processing system. Reliable code ensures that transactions are processed correctly every single time, with proper error handling and recovery mechanisms. Maintainability is about how easily other developers can understand, modify, and enhance your code. Efficiency relates to resource utilization and performance. This doesn't mean premature optimization, but rather writing code that performs well under expected conditions. For example, choosing appropriate data structures and algorithms for your specific use case. Adherence to best practices ensures your code follows established patterns and conventions. This includes proper documentation, consistent naming conventions, and following principles like solid and dry. These elements work together to create code that's not just functional, but also sustainable and scalable. In the DevOps context, high-quality code is essential for maintaining rapid delivery cycles while ensuring stability and reliability. The significance of code quality in DevOps cannot be overstated. Let's explore why it's so crucial and how it impacts various aspects of the software development lifecycle. First, let's talk about early detection of defects. In continuous integration pipelines, high-quality code with proper testing and validation mechanisms helps catch issues before they reach production. Efficient collaboration is another key benefit. When code follows consistent patterns and is well documented, teams can work together more effectively. Quality code enables developers across different time zones to contribute without constant synchronous communication. The impact on time to market is particularly interesting. While some might think that focusing on code quality slows down development, the reality is quite the opposite. High-quality code reduces the need for rework and debugging, ultimately speeding up delivery. When it comes to reliable and stable deployments, code quality is your best friend. Well-structured, properly tested code leads to fewer production incidents and more predictable deployments. This is especially crucial in a DevOps environment where frequent deployments are the norm. Think of code quality as an investment in your project's future. Just as regular maintenance keeps a car running smoothly, maintaining high code quality ensures your software remains reliable and adaptable over time. As we delve deeper into our discussion of code quality, let's establish a clear understanding of its role in the DevOps context. Code quality isn't just a development team concern, it's a crucial element that impacts the entire DevOps pipeline. In modern DevOps practices, code quality serves as a bridge between development and operations. It's not just about writing elegant code, it's about creating software that can be efficiently deployed, monitored, and maintained in production environments. I've observed that organizations that prioritize code quality in their DevOps practices typically experience smoother deployments, fewer production incidents, and more predictable release cycles. This is because high-quality code is inherently more testable, deployable, and manageable. The key is to understand that code quality in DevOps goes beyond traditional metrics. It encompasses aspects like operational efficiency, monitoring capabilities, and how well the code supports continuous delivery practices. As we proceed with this session, we'll explore these connections in detail and see how they come together in real-world scenarios. Let's examine the key factors that influence code quality in detail. Each of these factors plays a crucial role in maintaining high standards in your codebase. Code readability is perhaps the most fundamental factor. Clear, well-structured code isn't just about aesthetics, it's about reducing cognitive load and making maintenance more efficient. Test coverage is another critical factor. But it's not just about achieving a high percentage of coverage. Teams may fall into the trap of writing tests just to meet coverage metrics without focusing on test quality. What matters is meaningful test coverage that validates business logic and critical paths through your application. Consistent coding standards are vital for team collaboration. In one project, we implemented automated styling and linting tools, which reduced code review time by 30% and improved code consistency across the team. This isn't just about formatting, it's about making your codebase feel like it was written by a single, competent developer. Automation and tooling support these quality factors. Modern development environments offer powerful tools for static analysis, automated testing, and code formatting. These tools should be integrated into your development workflow and CI/CD pipeline. Code reviews, when done properly, can significantly improve code quality. The key is to focus on both technical correctness and maintainability. I encourage teams to use a checklist approach in code reviews, ensuring that all critical aspects are consistently evaluated. Each of these factors reinforces the others. For example, consistent coding standards make code reviews more effective, while good test coverage gives teams confidence when making changes. Together, they create a foundation for maintaining high code quality throughout your project's lifecycle. Let's explore the essential tools that support code quality in the DevOps environment. These tools are more than just utilities. They're crucial allies in maintaining and improving code quality throughout the development lifecycle. Code quality tools have evolved significantly over the years. From simple linters to sophisticated analysis platforms, these tools now offer comprehensive capabilities for ensuring code quality. They serve as automated guardians of your codebase, constantly checking for potential issues and enforcing best practices. It's not about using every available tool, but rather selecting ones that address your specific needs and challenges. These tools play a vital role in supporting both developers and the broader DevOps process. They provide immediate feedback during development, enforce standards during integration, and help maintain quality throughout the deployment pipeline. As we proceed, we'll explore specific tools and how to leverage them effectively in your DevOps practices. Let's dive into the two main categories of code quality tools: static code analysis tools and code review tools. Each type serves a distinct purpose in maintaining code quality. Static code analysis tools are your first line of defense. Tools like SonarQube, ESLint, and CheckStyle analyze your code without executing it, identifying potential issues before they reach production. For example, SonarQube can identify security vulnerabilities, code smells, and technical debt. ESLint helps maintain consistent JavaScript code style and catches common programming errors. CheckStyle ensures Java code adheres to coding standards. Code review tools, on the other hand, facilitate human interaction and knowledge sharing. GitHub's pull request feature, Crucible, and Gerrit make it easier for teams to collaborate on code reviews. These tools not only track changes, but also provide a platform for discussion and learning. The key is integrating these tools into your development workflow. For instance, you might run static analysis as part of your SCI pipeline and use code review tools during the pull request process. This creates multiple checkpoints for ensuring code quality. I've found that the most successful teams use both types of tools in combination. Static analysis provides consistent, automated feedback, while code review tools enable valuable human insight and knowledge transfer. Together, they create a robust system for maintaining code quality. Let's explore SonarQube, one of the most powerful tools in our code quality arsenal. SonarQube has transformed how teams approach code quality management and make a significant impact across numerous projects. The static code analysis capability of SonarQube is comprehensive. It doesn't just look for obvious bugs, it analyzes code patterns, complexity, and potential security vulnerabilities. When it comes to code quality metrics, SonarQube provides detailed insights into your codebase's health. It measures everything from cyclomatic complexity to code duplication, giving you a clear picture of areas that need improvement. These metrics are invaluable for making data-driven decisions about code quality. The Coding Standards Enforcement feature is particularly powerful. You can configure SonarQube to enforce your team's specific coding standards, ensuring consistency across the entire code base. This is especially useful for large teams or organizations with multiple projects. Continuous inspection is where SonarQube truly shines in the DevOps context. By integrating it into your CI/CD pipeline, you create a constant feedback loop that helps prevent quality issues from accumulating. Let's continue our exploration of SonarQube's capabilities, focusing on its advanced features that make it an indispensable tool in the DevOps toolkit. The security vulnerability detection in SonarQube is particularly impressive. It can identify various security issues, from basic vulnerabilities to sophisticated attack vectors. The integration capabilities with development tools make SonarQube particularly effective. Whether you're using Eclipse, IntelliJ, or Versus Code, SonarQube provides real-time feedback right in your IDE. This immediate feedback loop helps developers address issues as they code, rather than waiting for later stages in the development process. The reporting and visualization features are crucial for tracking progress and communicating with stakeholders. The interactive dashboards provide clear visibility into code quality trends and help teams make informed decisions about technical debt management. The community support and extensibility of SonarQube are valuable assets. The active community contributes plugins and rules that help keep the tool current with evolving development practices. Teams may create custom rules specific to their business domain, extending SonarQube's capabilities to meet their unique needs. Now let's look at how to integrate SonarQube directly into your development environment using Eclipse IDE. This integration is a game changer for developers who want to maintain high code quality standards while coding. The SonarQube Eclipse plugin brings the power of SonarQube's analysis right into your development environment. This means you get immediate feedback on code quality issues as you write code, rather than waiting for CI/CD pipeline results. The IDE integration also helps teams maintain consistency in their coding standards. When everyone on the team has the same quality checks running in their IDE, it becomes easier to maintain a uniform code quality level across the project. Let's walk through the process of installing the SonarLint plugin in Eclipse IDE. This installation is your first step toward implementing continuous code quality checks in your development environment. The installation process begins in the Eclipse Marketplace, which is accessible through the Help menu. While this might seem like a simple step, it's crucial to ensure you're installing the correct version of SonarLint that's compatible with your Eclipse installation. It's important to standardize the plugin version across all team members. This ensures everyone is working with the same rule set and getting consistent feedback. The installation process is straightforward, but there are a few key points to keep in mind. Make sure you have administrative rights on your system, as the installation may require them. Also, if you're working behind a corporate firewall, you might need to configure your proxy settings in Eclipse before accessing the marketplace. After clicking Install, you'll see a list of components that will be installed. Take a moment to review these. Understanding what's being installed helps when you need to troubleshoot later. The installation might take a few minutes, during which Eclipse will download and configure all necessary components. Now that we've installed SonarLint, let's configure it with server support. This configuration is crucial for teams working with a central SonarQube server, as it ensures consistency across the entire development team. The restart after installation is important. It ensures all SonarLint components are properly initialized. Skipping this step may lead to configuration issues that were difficult to diagnose later. When configuring SonarLint through the Preferences window, you'll need to provide server details. This is more than just entering a URL. It's about establishing a connection that will synchronize your local environment with your team's quality standards. The server configuration process requires attention to detail. Make sure you have the correct server URL, and if you're using authentication, ensure you have the proper credentials ready. In enterprise environments, you might need to coordinate with your DevOps team to get the correct server information and access rights. The configuration process also allows you to specify which quality profiles to use. This is particularly important when working on multiple projects with different quality requirements. I recommend documenting your configuration choices for team reference. Let's explore configuring SonarLint for standalone use without server support. This configuration is particularly useful for individual developers or small teams that don't have a central SonarQube server. After restarting Eclipse, the configuration process is straightforward, but requires careful consideration of which rules to enable. The standalone configuration gives you more flexibility in customizing your analysis rules, but with that flexibility comes the responsibility of maintaining consistent standards. When customizing rule sets, focus on rules that align with your project's specific needs. It's better to start with a core set of important rules and gradually expand as needed. Remember that without server support, you'll need to manually maintain consistency across team members' configurations. Consider creating a shared configuration file that team members can import to ensure everyone is following the same standards. Let's discuss the first option for configuring a SonarQube server, using the public Sonar Cloud instance. This option provides a quick way to get started with SonarQube without the overhead of maintaining your own server. Sonar Cloud is particularly useful for open source projects or when you're learning SonarQube. I've used it extensively in training environments and for proof of concept implementations. The public instance at sonarcloud.io offers many of the core features you need to get started with code quality analysis. However, it's important to understand the limitations of using a public server. While it's great for learning in small projects, you might face restrictions on project size and analysis capacity. When using the public server, be mindful of what code you're analyzing. Never upload sensitive or proprietary code to public instances. This is a crucial security consideration that sometimes gets overlooked in the eagerness to implement code quality tools. Let's explore the second option, setting up a self-hosted SonarQube server. This option gives you complete control over your code quality infrastructure and is typically the choice for enterprise environments. Setting up your own SonarQube server requires careful planning. You'll need to consider factors like server specifications, database setup, and backup strategies. Proper sizing of the infrastructure is crucial. Following the official documentation is essential, but there are some practical considerations that come from experience. For instance, ensure your server has adequate memory for analysis of large code bases, and consider setting up monitoring from the start to track server health. The authentication credentials for your self-hosted server should be managed carefully. Implement proper access controls, and consider integrating with your organization's existing authentication system. SonarQube may be integrated with Active Directory or LDAP for seamless access management. While setting up a self-hosted server requires more initial effort, it provides benefits like complete control over data, customizable rules, and integration with internal tools. This makes it the preferred choice for organizations with specific security or compliance requirements. Now let's look at how to analyze code using SonarLint in Eclipse. This is where you'll start seeing the immediate benefits of your setup work. The analysis process is straightforward. You can analyze individual files or entire projects with a right click. However, the real value comes from understanding how to interpret and act on the results. The on-the-fly analysis is particularly powerful because it provides immediate feedback as you code. This instant feedback loop helps developers learn and adapt their coding practices in real time, rather than waiting for later code reviews or build processes. The analysis results will highlight various issues, from potential bugs to code smells. The key is not to view these as criticism, but as opportunities for improvement and learning. Understanding how to effectively view and interpret SonarQube issues and metrics is crucial for improving code quality. The SonarLint on-the-fly view in Eclipse provides a wealth of information that can help you make informed decisions about your code. When examining issues, pay attention to both the severity level and the type of issue. Critical issues should be addressed immediately, while minor issues might be scheduled for later cleanup. The location information provided with each issue is more than just a link to the code. It's an opportunity to understand patterns in your codebase. Look for recurring issues in similar parts of your code, as these might indicate broader architectural or design problems that need addressing. Making improvements based on the feedback is an iterative process. Start with the most critical issues and work your way down. The ability to synchronize your local analysis with the SonarQube server is a powerful feature that helps maintain consistency across your development team. This synchronization ensures everyone is working with the same quality standards and rules. The synchronization process is simple but important. When you synchronize, you're not just updating rules, you're ensuring your local environment reflects the latest quality standards defined for your project. The right-click synchronization option makes it easy to stay up to date. However, it's important to establish team practices around when to synchronize. Some teams make it a habit to synchronize at the start of each day or sprint to ensure everyone is working with the latest rules. As we conclude our discussion on code quality and SonarQube integration, let's take a moment to reflect on what we've covered. This is an opportunity to think about how these tools and practices can be applied in your specific context. Consider how you might start implementing these practices in your own work. Perhaps begin with installing SonarLint in your IDE, or start discussions about setting up a SonarQube server for your team. Remember that improving code quality is an iterative process. You don't need to implement everything at once. I encourage you to experiment with these tools and find what works best for your team. The questions you ask and challenges you encounter will help you build a deeper understanding of code quality practices.